So now, because n is greater than, as assumed that n is greater than this maximum. When n is greater than the maximum of two numbers, that means n must be greater than all of them. So actually, this will become two inequalities. N greater than 9 multiplied by this. Another inequality, n greater than or equal to 9 multiplied by this. So you do it separately and try to get do some algebraic operation to get these two equivalent inequalities.
Okay. Thank you.
Okay, I have seen some of you had got this question right. Now, to answer such kind of question, I just want to explain how we tackle such kind of question in general. Now, it is a problem about estimator. And about estimator, there are two quantities that we are interested, which is the bias and the variance. It tells us the performance of the estimator. So according to the definition, bias of an estimator is equal to the expected value of it minus the parameter that we want to estimate. So if you want to determine the bias of an estimator given in this question, we can substitute into this formula. So bias of theta hat equal to expected value of kx bar minus theta, where this x bar is the sample mean. And the question is asking us what value of the k will make this estimator unbiased. Unbiased means the bias becomes 0. So to tackle such a question, we need some basic knowledge. These are the basic knowledge you need to acquire. First of all, for any random sample, the sampling distribution of the sample mean will have an expectation equal to the population mean. And the variance of the sample mean would be equal to the population variance divided by the sample size n. So this is a general property for a random sample. So this is important and you need to remember. So based on this property, the bias can be evaluated as k multiplied to the expectation of x bar, so that will become mu minus theta. But what is the value of mu? Then you also need another piece of knowledge related to the distribution. The question, according to the question, it says that the sample was drawn from a uniform distribution within the range from 0 to theta. So the population mean, population variance will be determined according to this distribution. So you need to know how to find the mean and the variance from this distribution. So you may refer to the topics related to the uniform distribution. You will find this formula. The mean would be equal, mu is equal to the midpoint of the interval. The sum of these two endpoints divided by 2. And the variance would be equal to the square of the length of the interval, b minus a, divided by 12. So this is a mathematical result, derived according to some integration. So we make use of this formula. We'll find that when k is equal to 2, the bias is equal to 0. An estimator with bias equal to 0 is said to be an unbiased estimator. It is a nice property. We would like our estimator to be unbiased, so that on average we're actually estimating the target. So the answer is equal to 2 for this question. Now after we find the k equal to 2, the second part of the question asks us to determine the variance of this estimator. So we put k equal to 2. The estimator is equal to 2 multiplied to the sample mean. Now, if we want to find the variance of this estimator, we need to find the variance of 2 multiplied to the sample mean. Then you need to know how to evaluate this variance. We do it step by step. When we have a constant multiplier inside the variance, we can take this out of the variance, but we need to take the square of it. So this is a property of the variance operation. So you also need to know this basic knowledge. Whenever you have a constant multiplier inside the variance operation, and you extract this out of the variance operation, you need to take the square of it. Now the variance of sample mean, as I mentioned before, from a random sample, the variance of sample mean is equal to the population variance divided by the sample size n.
So we also make use of this formula. Now, of course, we also need to determine the variance. Then according to the uniform distribution, we have a formula for the uniform distribution. It is equal to b minus a squared divided by 12. Here a is equal to 0, b is equal to theta. So that the population variance is equal to theta squared divided by 12. So finally, we can find the answer. The variance of this estimator is equal to theta squared divided by 3n. And finally, the question is also asking us that what will happen when n tends to infinity? We see that because the denominator is a function of n and the numerator is just a constant, so when n tends to infinity, this ratio tends to 0. So we need, for this kind of question, if you want to solve it, you need to do it step by step, starting from definition, and try to find the formula that will give you each quantity in each step. Okay? So it requires quite a lot of basic knowledge. Okay? And if you can remember all this, you can try to refer to the notes, find the corresponding session of the lecture notes or the video, and try to find those formula for you to solve this kind of problem. And practice makes perfect. As long as you have done quite a lot of this kind of question, then eventually you can remember everything. Okay. Now, let's turn back to question number 4, which related to random samples from another distribution, which is the normal distribution. And this question, again, you need to make use of some particular result or formula, and I've copied it here. Try to work on this question.
this, the range of this is wider than this one.
Yeah, I would prefer. Thank you.
Join the graph for this and the easier to.
okay, maybe explain a little bit about the walkthrough of this kind of question. Then we can move on to the next question. Now, in this question, according to the description of the question, it says that we have two random samples drawn from the normal distribution. So we have two random samples drawn from the same normal distribution. So we may denote them as X sample and the Y sample. The first sample denoted by X, the second sample denoted by Y. And the sample size of the first sample is 10. The size of the second sample is 15. And what we are asked is to compute this probability. The probability that the difference between these two sample mean will be greater than 0.3. So to answer this question, first of all, we need to know how to find out the distribution of the difference of these two sample means. Now we will need to make use of the basic result about a sample from the normal distribution. Whenever we have a random sample drawn from a normal distribution with mean mu and variance sigma square, then the sample mean will also follow the normal distribution. But the expectation will come the same as the population mean, but the variance will be the population variance divided by n. And this is a general result. Whenever you have a random sample from the normal distribution, we will always have this distribution for the sample mean. And besides this, we also have the sampling distribution for the sample variance. S squared is the sample variance. Here, S squared is equal to 1 divided by n minus 1, the sum of these square deviations. Okay. But in this question, we don't need to use the sample variance. Okay. But these are the general results for the sample from the normal distribution, and in fact, these are the foundation of most of the statistical analysis. Now, in this question, we just need to use this part. So based on these two samples, we know that the sample mean from the first sample will follow this distribution. The sample mean of the second sample will follow this distribution using this result. But what we are asking is the probability of about the difference of them. So we will need to further consider the difference of these two normal random variables. So the sample mean of the first sample minus the sample mean of the second sample, we know that if you have two independent normal random variables, you take the sum of them or you take the difference of them, the result will be also distributed as normal. With the mean equal to the same operation on the corresponding population means. You add them together, this will be the sum. You take the difference, this will be the difference. Okay? But for the variance, we are always adding up. So no matter whether this is a plus sign or a minus sign, the variance of this difference or sum will be always the sum of the variance of them. So in this problem, it will be 3 over 10 add to 3 over 15. Okay. The difference between two normal random variables will follow the normal distribution, with the mean equal to the difference of their means, the variance equal to the sum of their variances. So this is also a general property of two independent normal random variables. And this will become 0 and half. So once you get this result, the rest will be just a typical problem of finding a probability of related to a normal random variables. So this probability will become 1 minus the probability. That's, maybe I write this in this form. Okay. Because we are asked to find the probability that the difference is greater than 0.3, so it is equal to 1 minus the probability that the difference is within 0.3. is from minus 0.3 to 0.3. So this can be expressed in terms of the CDF of the standard normal. Okay. I don't have a calculator here, so I just copy this here. It will be equal to, what is it? Using a calculator, you can find this quantity. So I suppose you know how to evaluate the probability related to a normal random variable using the CDF. Now, to find this number, you need to make use of the standard normal distribution table, okay? Or you can use R. Recall that from the lab, you've learned about this function, P norm. P stands for the CDF, probability function, of the normal distribution. So you just input the S value. Then you can find the CDF of the quantity for a standard normal. When we don't input the mean and standard deviation, by default it will be the standard normal. Okay? So then you can get the answer by using R. Or you can use the standard normal distribution table. You'll get the same result. Is there any question? So actually, everything were already given in the solution, and there will be handwritten solution. There is also a video for this walkthrough. But I hope that you can try to follow the logic. So from each step to the next step, why we go to the next step according to a purpose. We have a purpose to find the probability. And the probability is in terms of a random variable. So we need to find out the distribution of that random variable. And how to find the distribution of that random variables? Then we rely on this kind of property of a sample from the normal distribution, and doing it step by step to get the answer. Is there any question? Now, I still have a little time, so maybe we can try to think about question number 1 related to the normal approximation to binomial.
That's
Because
why.
the table is not complete. Usually for the classical distribution table, you just give the contour for some particular probability. Because if you want to have a table like the normal table with so many probability, then you need a book of tables for this. actually was given in the worksheet. The worksheet states that we can use the function PCHISQ. And use this function.
Let me stop that.
And you need to input two numbers. One number is the x value, another number is the degrees of freedom,
Okay.
which is the 9 here. So you need to input 15 and 9 into this function, and you will get this probability. And 6.25 and 9 into that function, you will get this probability.
Thank you.
Okay, time is running out, so maybe I just state a few key points about this question. Now, this is a typical question about how we can make use of the normal distribution to approximate a binomial distribution. Now, first of all, in part 1, we can easily identify the distribution of y. Y is the number of passengers, or actually the number of ticket holders who show up during the flight. So totally, there are 267 ticket holders. Each of them will no-show with probability 6%. In other words, the probability that each ticket holder will show up is equal to 0.94. So we have 267 Bernoulli charts. Each of them will have 0.94 chance to be a success. So the number of passengers or number of ticket holders who will show up in the flight will follow a binomial distribution. With n equal to 267 and p equal to 0.94. So according to the formula of binomial distribution, we know that expectation of a binomial random variable is equal to n times p So this is how we can find out the mean and variance of these binomial random variables. The variance is 1 np times 1 minus p. Okay, so this is how we answer part 1. Now the problem here actually is part 2. I know that you may not be able to answer part 2 because it was not taught at all. So in part 2, we are asked what is it appropriate to approximate the distribution using a normal distribution. Now, normal approximation is very useful because we have used the normal distribution to approximate a lot of different distributions. But we have some conditions. We need the sample size to be large enough. And we also need the original distribution not too far from normal. What does it mean by not too far from normal? It is not too skewed. It is not too far from symmetric. So for binomial distribution, actually we have a rule of thumb. Now this is actually not taught, but it is also part of the content of the second question. So I would like to explain a bit about this because I find that some students from the previous class, they have a lot of questions about this. Now, according to one of the rule of thumb, whenever the sample size is greater than this quantity, then we'll say that the normal distribution can well approximate the binomial distribution. So actually, this is what the question is supposed to, we are supposed to do to answer this question. We check this condition to see whether the sample size is large enough. Large enough means it is larger than this quantity. Actually, you will find that if you do this kind of calculation, you also guarantee that when n is greater than this, n is large enough, and also p is not too small, not too large. When the p is not too large, not too small, that means the distribution is not too skewed. Okay? So that we can use the normal distribution to well approximate the binomial under this condition. So what we need to do is just to check this condition. 9 multiplied to 1 minus p over p is equal to 9 multiplied to 0.06, 0.94. It is equal to 0.57. 9 multiplied to p over 1 minus p is equal to 9.94 divided by 0.06, which is equal to 141. So n equal to 267 is greater than the maximum of 0.57 and 147. Okay? 267, the sample size in this question, is greater than or equal to both of these two numbers. So it is greater than the maximum of them. So in other words, the condition is satisfied. So it is appropriate to use the normal to approximate the binomial for this distribution. Okay. Any question? So actually, in second question, you are asked to do something related to this condition. Now, after part 2, in part 3, part 4, and part 5, we are also asked to approximate the probability that flight will take off between 248 and 255 passengers. So each of these questions is asking us to evaluate probability, but we want to approximate using the normal. So this is the probability y greater than or equal to 248, smaller than or equal to 255. Right? It looks like we are asked to evaluate this probability. But the trap here, there's a trap here. In the question, it says that the flight was overbooked. Actually, the aircraft have only 255 seats. So that means no matter how many passengers show up, the maximum passengers of the flight will be 255 at max. Even when there are more ticket holders show up, okay, they will be transited to another flight. And therefore, what we are actually asked to compute here is this probability. Because the number of passengers of the flight cannot be greater than 255. So to find this probability, we can use the normal approximation. Normal approximation means we just treat this y as a normal random variable, although it actually follows the binomial. But we just treat this as normal.